Hi everyone, welcome to Unit8 Talks, our webinar series on business and technology. Today we'll discuss Data Vault with Adrian Zapater, data engineer at Unit8, and Amadej, data engineer at Unit8 as well. My name is Billy Yen, and I will be your host today. For those of you who are new to the series, we are Unit8, a Swiss data analytics and AI company driving the adoption of data science in the industry and committing to sharing our best practices. This session is for you, therefore, please ask any question by commenting on LinkedIn, YouTube, or Twitter. Ready? Let's give the floor to Adrian and Amadej. Guys, present yourselves and introduce the agenda.
Hello, I'm Adrian Zapater. I'm a data engineer at Unit8, and I've been helping banks build scalable data pipelines for the past 3 years. Today, I will introduce you into the dateable data modeling world and try to answer the question that many of you have in your minds. Is dateable right for me?
Hi, my name is Amadej. I'm a data engineer at Unit8 as well. And in the previous years, I've been working on several software development projects and data engineering topics. And for the past year or so, I've been part of a Data Vault implementation team who are implementing various components to a Data Vault solution to a large-scale bank. And today, what we are doing is presenting Data Vault, and I will be presenting data warehouses in general, and then diving deep into the Data Vault architecture in particular.
Sounds great. Let's start.
Welcome, everybody, to the presentation about the Data Vault model. So let's go over the agenda again. So we will start by introducing data warehousing in general and continue with the Data Vault. First, we will look at the Data Vault architecture, which is the macro perspective, and then the Data Vault modeling, which is the micro perspective. Finish with the conclusion and with a live Q&A session in the end. So what is data warehousing? What is a data warehouse? Well, it's in a nutshell, it is a system with all the enterprise data that enables you to perform complex analytics queries in a very efficient way, which will enable you to create amazing business decisions. So it is a central repository of integrated data, acting as a single source of truth and an essential component of any business intelligence systems. Usually it consists of several layers: staging, data warehouse, and data mart layer, but more about it later. To contrast it with typical relational databases, it is designed to handle big, heavy queries for analytical processing and reporting, unlike a lot of very lightweight queries like we see in a relational transactional database. So what does a data warehouse achieve? It achieves consistency of the data. So if we have a sales team, marketing team, finance team, for example, they could have different sorts of data with different sources, and their numbers don't always add up. They're not always unified, and we need a consistent single source of truth where we can really rely on those data. And this is exactly what a data warehouse does for us. In this way, it enables us to make good business decisions. And it also provides us with the historical overview of the data. So not only does it keep currently valid records, it also provides us with all the historical values of those records, which is something that traditional relational databases are not designed to do. But this is one of the main differences. So what the data warehouse also does is it prevents duplicate work, because efficient queries handled by data warehouse are unified, have unified data cleaning standards, and also efficient processing of analytical queries, simple and effective way to gather insights to make business decisions. So let's look a bit into the history of data warehousing. It all started in the early 90s with the Inman architecture. This is a top-down approach and a 3-layer architecture. So we have the staging layer, the data warehouse layer, and the data mart layer on top of it. So the data mart layer is the layer where the data is exposed to the consumers, but first it needs to be in the staging and data warehouse layers. So what do those layers do? Well, the staging layer, it normalizes the data and provides atomic data at the lowest level of granularity. And then only after the full data warehouse has been created, one would create the data marts. So here we see that the Inman architecture requires a lot of upfront work to be done, because only then we can add the data marts and expose the data to the consumers and get value out of our architecture. The limitations, apart from a lot of upfront work, are also complex design. It increases as more tables are added to the model. And the changes to the data are very difficult to absorb and have a high impact on the data mart layer. I would also like to add that this architecture comes with a cost in terms of heavy processing in the staging layer, which limits the throughput and ingestion capabilities, because we have to normalize the data and clean the data before ingesting it into the data warehouse. Then the next architecture, which emerged in the mid to late 90s, was the Kimball architecture, which is a bottom-up approach. It has only 2 layers, and it's very limited in terms of flexibility against new changes. Here we have denormalized data, which are organized into data marts modeled using the dimensional model, easy and efficient to query. Business rules have to be implemented before the data mart layer, so limited flexibility against business requirement changes. And adding a second dimensional model over the same data is more complex. So a major drawback of this architecture is that it is very difficult to handle new business requirements, new tables, and it just doesn't scale that well. And it entails a lot of maintenance work, a lot of work as we continuously use it. And then with new millennia coming around in the year 2000, we were given the Data Vault architecture, which aims to get the best of both worlds. It is a top-down architecture with a bottom-up design, with a refined 3-layer architecture, and it's designed to overcome the limitations of the previous traditional approaches. So we have 3 layers, a refined staging layer, the main data warehouse layer, and the information mart layer. And let's look into the exact architecture of the Data Vault in the next slide. The Data Vault architecture, otherwise known as the macro view of the Data Vault. Let's jump straight into it. So Data Vault is a scalable data warehouse architecture. It is a refinement over the typical 3-layer architecture. So let's look at the diagram. Here we have the diagram of the 3 layers and the entire architecture, and the data flow is from left to right. So on the left, you have the source systems, so from the sales team, finance team, contracts, data get ingested through the staging layer onto the enterprise data warehouse layer, and finally into the information mart or information delivery layer on the right. So starting with the ingestion systems, we apply hard business rules to get the data into the staging area. What are hard business rules? Hard business rules are basically just data type impositions, which occur when you load data from one source to another. And this is where it gets into the staging layer. And the staging layer is the layer that has no historization of data, and it is a temporary layer. Here we apply no changes to the source data, only hard business rules get applied, and the common columns are computed here, hashes, load date, sources, so the data that, or the auxiliary data which will be used for housekeeping purposes later on. And it is a compulsory layer in the data vault architecture. Moving on, there is the enterprise data warehouse layer, or simply the data vault layer, which contains the raw vault, the business vault, metrics vault, and operational vault. And the raw vault is actually the only mandatory sublayer there is that we really need to have. So it is the heart of the data warehouse. It stores the data ingested from the source system without applying any changes to it. So it contains maybe a business concept, let's say customer, and all the raw attributes of this customer, like, for example, the birth date, the age, the credit rating, and so on. So mainly just the data that we just source from the system without any business logic applied to it. Then we store all the data, good or bad, for auditing purposes in this raw vault layer. And then the business vault layer, which is an optional layer, is an intermediate sublayer between the raw vault and the information mart layer. And this is where the soft business rules get applied. Let's say you want to, based on certain conditions, the customer gets flagged or not flagged. So you would need an additional column, let's say a Boolean value, true or false, of whether the customer is flagged as being, I don't know, creditworthy or not. Then you can do that in the business vault and compute that extra column. So no need for materialization. Data can be exposed as views. New derived attributes are computed here from soft business rules. So that's the business vault. And then you have other optional vaults like metrics vault, where you capture runtime metadata to perhaps detect some computational bottlenecks. And the operational vault, which is a component for that is used for the use case of streaming data, direct access to raw data from operational systems, reading and writing is supported, faster and more efficient than using a data mart. And then finally, on the right, we have the information mart or data mart layer, which essentially exposes our data to the data consumers, to the users. We expose these data in forms of reports or in star schemas. And to really design this part of the architecture, it's best to sit down with the consumers and really ask them what kind of attributes or data they want to see, and arrive at the conclusion together. So this was an overview of the data vault from a macro perspective. And later on, Adrian will show you how it looks like from the micro perspective in the modeling slides.
So now it's time to talk about the modeling aspect of dateable. But first, let's take a step back and try to give a definition for modeling. So modeling can be thought of as the art of identifying the business objects or business concepts that are hiding inside of the data. We understand these business concepts, understand how they relate between each other, and finally translate this into a data model. We've already seen two different approaches to the data modeling. There's a normalized approach used normally in the in-months approach to the data warehouse, where data is stored in the third normal form with low data duplication. But there's also the normalized approach, where data is organized into different dimensions. This is called the dimensional modeling, introduced by Kimball, and usually used on Kimball's approach. Finally, Data Vault lies between, in the middle of those two approaches. It's a kind of a hybrid between the normalized and the normalized approach, where we store the data as it is found on the source system. So no further normalization, no further denormalization. We just store the data how we find it on the source system. And if it's already denormalized or denormalized up to a degree, we keep it that way. If it's normalized, we continue that way also. The main design after the dateable model is inspired by networks that occur naturally in the nature, such as we can think of it, for example, the neurons in the brain, where we have hubs or nodes and links or edges that connect these hubs together. On the dateable model, each of these hubs represents a business concept, a business key. And these links model the relationship between these business concepts together. Data Vault also puts a very big focus on identifying the business keys and the business objects, trying to really understand how the business accesses this data and works with this data. If we manage to really identify correctly these business objects, we will be modeling very closely the business. So our data model will be very closely related to what the business really is doing. And this gives us the flexibility to adapt to the big changes introduced by changing business requirements, and also the agility to do so very fast. We will see more on this on the next section. So the Data Vault model is built over three basic components: the hub, the link, and the satellite. Each of these components has a single responsibility that doesn't overlap with the other components. This is what gives Data Vault, or the Data Vault model, the flexibility and the agility that it provides. No, we can think of this responsibility as the single responsibility principle in the solid design principles of software engineering. By having each of the components with a single responsibility that doesn't overlap with the rest, we limit the number of entities that need to be changed in case there's a change in requirements. In this case, if we look first of all at the hub, which could be thought of as a table that keeps track of a distinct collection of business keys, and each of these hubs is going to model one business object, a business concept. Okay, the hub's responsibility is to decouple the management of the business keys from the rest of the attributes. So here we will only store the business keys. We will only store the information needed to identify each of these business objects and business concepts. So any changes to the way we identify the business concepts, you will have to change the hub, but you won't have to go and change the model of the link or the model of the satellite. And that's the key. And that's where the flexibility and agility of Data Vault comes from. If we switch to the link, here a link, and going back to what we talked about, the Data Vault model being a network, links model the relationship between one or many hubs. They model associations, they model hierarchies when one business concept is associated against itself. And they are always modeled as a many-to-many relationship if we think of the third normal form. So there's always a table that keeps track of the IDs of the relationship. And you may be thinking, like, why are we modeling this as a many-to-many relationship? Because sometimes you may have a one-to-one relationship also, which is it's more simpler to model, and you don't need an extra table for this. So this is part of the scalability and flexibility that the Data Vault design has in mind from the beginning. If you model everything as a many-to-many relationship, any change on the business requirements that change the relationship between two entities will be absorbed by this link entity. And out of the box, you will be able to, without any changes, you are already able to model and accept this kind of relationship. Whereas if you went for a 3 normal form implementation, you will have to change the model and impact all of your pipeline. Last but not least, we have the satellite. Up to now, we've only talked about business concepts and relationship between business concepts. But where is the data? Where is the context of these business keys stored? And the place is the satellite. The satellite will keep track of all of the descriptive attributes, all of the information that describes these business objects. And so it kind of adds context to these hubs, or even to the relationships, to these links. And the satellites, or we can use the satellites really to keep track also about time dimension. We can use the satellites to not only store the attributes, but the changes in the data, the changes in these attributes. So we could model satellites as a type 2 slow changing dimension, and keep track of the validity of each of the attributes for a given business object, and even keep track of all of the versions from this business object. So we would be able to go back in time and ask the question, what happened when? On the next section, we will look into the conclusions and advantages of the dateable model. Now, let's take a look about a summary about the advantages and disadvantages of dateable. So on the advantages side, we've already talked about the flexibility that the dateable model brings onto the table, and how this is achieved by modeling as closely as possible the business, and by having this very clear separation of responsibilities between the different business concepts. The dateable model also brings transparency and auditability to your pipeline. So thanks to the metadata that keeps that we store in each of the entities, we are able to answer the question of which source system delivered what, and also what happened when. So we keep track of the source of the information, and also the different versions of this information. So we could potentially go back in time and see the data as it was on a previous or an older date. Datable is designed from the beginning as a scalable solution. So scalability has also always been in mind, from the ingestion process, scaling up to petabyte scale data scale, and also on the management side, to be able to have teams collaborating and working together. You can, when you onboard new source systems, it's very easy for each source system to model their own data, add them to the data warehouse, and integrate it with the existing work from other teams. So it's very easy, very fast to get everyone and all of the source systems onboarded into this data warehouse. Datable also, and this we haven't really covered up to yet, has standardization also in mind. So by having 3 basic components, it's easy to automate the generation of these components, and this will help you and your teams just deliver faster by automating boilerplate code and boilerplate logic through this standardized approach. Each entity has a common structure, so it's easy really to model after it, and to have templates that you can reuse around. But all of these advantages come at a cost, and Datable also has some disadvantages with it. To be able to work with the Datable architecture, you need experienced data engineers with at least high-level engineering skills and that also know and understand the data vault. By having so many entities, by tackling the complexity of problems by creating new entities into the model, it has a very large storage requirements. And also, if you want to keep full auditability and keep track of the full history of the data, this can even be bigger because you will effectively keep track of every single version that the system has seen. There's ways to lower this, or there's ways to mitigate this problem, but in general, it's a data model and data architecture that has duplicated information and a very high number of entities in the model. This also brings a bit of cognitive overhead because it's sometimes it can be difficult to keep track of so many entities in a model, in a data model. Also, we've talked about links being modeled after a many-to-many relationship. This means that more joins operations need to happen, even for simple relationships like a one-to-one where only one join would be needed. Every single link from one business concept to another one will need at least 2 joins to be able to be performed. Again, there's ways to mitigate this by the introduction of more advanced entities of the dateable models, such as the bridge tables. But overall, it's a model and an architecture that requires many more join operations than a denormalized one. Finally, we already know that dateable uses the 3-layer architecture, and on this 3-layer architecture, we have sublayers. This is very good for flexibility and to adapt to changes, as we have many layers to absorb the business changes. But the problem that comes with this is that it takes more time from data from the source system to get to a data mart. Again, there's ways to mitigate this, and if you really need a fast lane to get data from, let's say, a near real-time or real-time use case, and ingest data or streaming data and really get it out as soon as possible, there's ways that you can use the dateable model to mitigate and limit the amount of time that it could take. But in general, having so many layers means that the data gets, it takes longer for the data to get to the information mart. Let's try and answer the question that everyone has in mind. Is dateable right for me? So to answer this question, we need to think about the requirements of the use case that you have at hand in this moment. So let's try and, we've listed here some of the requirements that are a very good match for use cases that need to use dateable. Then, depending on which of these requirements you have in your use case, you'll be able to decide if you really need dateable or you can use one of the other alternatives. Dateable is really good for auditability requirements. If you have a use case where you need full auditability, full history of the data, and keep track of the different versions, dateable is really good for this. As we've seen, you can keep track of these versions in the satellites, and you will be able to answer the question of what happened when and which source system delivered the information. It's also really good for use cases where we need to integrate lots of source systems together. As it has scalability at the center of the design, and it's been designed thinking of scalability not only in data size but in team size or organization size. You can have each operational system or each source system with its own engineers that understand the data, model that part of the data, and add their entities to the data warehouse. Integration between the different source systems is going to be very easy thanks to the hubs and the links and these relationships between them. And so you can effectively have many teams collaborating towards a common goal and building the common data warehouse everyone. Dateable is also very good for the heterogeneous source data scenario. So having data in different formats, or even from different systems, or using different technologies. Here, as we try to keep the data as it is on the source systems, on the robot and provide historization over that, we are able to ingest data in many formats, and later on down the path on the business vault layer, for example, or even probably in the business vault layer, you would extract this information and integrate it using business logic to union all of this, and changes and any sort of change that happens on the source data or on these integration processes will be absorbed on that layer. You will always have the robot to keep track of the different versions of the data and go back, and so you still have the auditability even though you are performing the business logic later on. Finally, dateable is also a really good. It's really good for high ingestion throughput use cases, because if you compare it with the other architectures such as Kimball or Inmon, we have a very, very light staging layer. Data gets ingested into the data warehouse very quickly. We just keep the data as it is from the source system. So it's very good for high ingestion throughput use cases where we need to gather lots of data into the data warehouse. That's all of the advantages and disadvantages of dateable. Now we will do a short Q&A so that we can answer all of your questions.
All right, so we saw a couple of questions. Maybe let's take on the first. One of them was about an example of a hub and a link. So maybe I can just touch again on this point. So the main idea of a hub is to make sure to track every single instance of a certain business concept. For example, you have customers and you track every single customer, and then you create records, and the typical columns that the hub would contain would be original identifier, record source, hash key, and the load date. So you would have a row for each of those instances. Or for example, a product, you have, again, these data for the product. Now, a link is when you want to connect two of those business concepts. For example, when a customer buys a product, that's a purchase. And the purchase is then created by a link between the customer and product. And to track these kinds of business concepts, you use links.
Okay. Oh, sorry. I think that before there was another question that said, what are your thoughts on the landing layer and how do you separate that from the staging layer? What about the methodology? What about the loading methodology? Okay, he meant the staging area. Okay, so I think when you're talking about the landing layer or the staging area, for example, we talk about the data lake architecture, no, with this layer where we just pour every single data source into it, and we store the data as it is, and we even keep all we kind of historize it. No, we store all of the multiple versions that we have, so that we can at some point go back and reprocess part of the pipeline because we found an error or whatever. That would be maybe the staging, the landing layer that you're talking about. If we compare that to dateable, so in dateable, we don't really need this landing layer anymore. We don't need to historize and keep track of all of the data from the source system and all of the versions that they delivered, because we are already keeping track of that, all of the versions in the robot. Here, the staging layer, you can think of it as like a lightweight landing layer where we that's used sort of like a buffer. So the data we will load inside the staging layer, the data we want to ingest into the robot, to our data warehouse, and we will keep it there until we process it and we manage to get it inside of the robot. As soon as it's on the robot, we are deleting that that information from the staging layer because we don't need it anymore. We already have everything that we need on the robot. And I think that would be the biggest difference between the landing layer in a data lake and on dateable. That it's much lighter. It's like a buffer. It's no historization inside of on the staging layer in the dateable. And just as soon as we upload it into the robot, we just remove it.
Then there was another question, why are the new derived attributes only computed in the business vault or information mart layer? Can't we compute it on the raw vault layer? So yeah, the answer is no, we can't. The raw vault layer is really only for loading and storing the data, and then also keeping track of the historization. Yeah, and it's only loading already existing attributes, the raw attributes. But if we want to, compute a new business derived column, then we need to do it as a separate step.
Yeah, and I would just add that so if we on the business, so imagine that we did it the other way around. Imagine that we go and we calculate, instead of storing the data as it is on the robot, we store a computed value using maybe some sort of business rule that we can make it just for the sake of an example. If a value is bigger than 10, return true. If not, return false. Really simple. And we are storing that on the robot. What happens when the business realizes that instead of using 10, they really wanted to use 20, and they are changing the requirements on that? As we haven't kept track of the original value, we've only stored the computed value, we cannot go back in time and like update the old data with the new logic, because we don't have that data anymore. And that is part linked with the staging question that I answered before. We don't have this landing layer where we can go back and retrieve the information and reprocess it again, because that historization only happens on the robot. And that's why it's so important to keep the data as it is on the robot and only compute derived attributes on the business vault. Because if we change the logic, we have the robot to go back in time and reprocess the information with the new business logic.
So yeah, like usual, the answer is historization.
Indeed. Okay, let's see what else do we have here. Can you mention existing data warehousing solutions that use dateable as their underlying architecture? So, to be honest, I don't really know big or well-known data warehousing solutions that tell you on their description of the page or their information that they use dateable. I'm pretty sure that many of them use dateable up to a certain point in part of their solution, but I cannot give you like specific names. What I can give you is tools, or like there's a tool called DBT. Not sure if maybe you guys know it. There's a framework, a dateable framework for DBT, very nice. It helps you automate and the generation of these entities, and yeah, it supports dateable, but I don't know any data warehousing solution names that use it. Do you, Amadej? Or
no, I will have to also pass on this one.
Okay, what else do we have here? Can we have a link joining a hub and another link? All right. So this is a question that comes up a lot, very frequently. So imagine this scenario. You have built your model, You already have 2 hubs connected by a link, and suddenly you realize, oh, it's now instead of having this link between these 2 hubs, I want to add a third one. And you will say, okay, the easiest way probably is, instead of remodeling this link or creating a new link that joins the 3 hubs together, let's create a link that joins the previous link with the new hub. And this is a situation that comes up a lot of times. The problem with this approach and why we shouldn't, and never we shouldn't link a link with hub is because it's not scalable. It's in that moment, you think it's the best solution ever. You just need to create a new link connecting to the other link, and all of the previous work is already reduced. But in the moment you put that in production and some changes come around, you're going to find yourself having lots of trouble, because now you have 2 links to maintain one type of relationship. So it's double the effort to maintain. And to compute the second link, you need all of the columns and all of the information needed to compute the first one, because like the way you identify one of the relationships is with a hash key, which is computed by the values of the keys involved in both of the hubs. So you already need that information in order to add the second link. So in the end, you're not taking advantage of anything. And the correct solution would be to close the first link and create a new link that joins the 3 business entities, so the 3 hubs together. Okay. What else do we have here?
So at the end, there was a remark about the last slide with error mart, how error handling and error processing happen in this model.
Mm-hmm. So, yeah, I mean, the error mart is just a sublayer where you would store, well, on the error mart would be the sublayer where you would store your tables, where, for example, for discarded rows, imagine yourself having a computed value and a very important computed value that in the event of having no values or not unexpected output, you don't want it to reach the data mart, the information mart layer, for example, or one of the applications that comes afterwards. So the error mart would be the place where you would store in a quarantine those rows and metrics around that kind of information. No? So the normal use case would be probably to just quarantine those rows there and don't let them through. But you could maybe build a dateable model around the metrics on what's the percentage of errors on a certain key, or I mean, you can get imaginative really on on there. But that would be the place that the methodology leaves for this kind of information. Okay. Come on, we have time for a few more questions if there's any. Yeah. If not, maybe we can drop it here.
Yeah, thank you for all the questions.
Thank you, Adrian and Amadej, for the insightful session.
Thank you, everyone, for joining. I hope you now have a better understanding of what dateable is.
Thank you for everybody's time, and I hope you got a lot of value out of this presentation of the Data Vault.
Yes, and follow us on LinkedIn, YouTube, and Twitter to be updated about the following sessions. You can watch the previous episode on our YouTube channel. We wish you a great evening. Bye-bye.
Bye.